Dear student, today we are going to discuss another very interesting topic of a numerical method known as a numerical differentiation. Basically, there are three methods in order to find out a value of a derivative numerically for any given set of data. So, how many types of a method? As we say that there are three methods, three type of a method to find out a numerical differentiation. First one is a method based on a interpolation. Method based on a interpolation. Based on interpolation. Interpolation. Method based on a interpolation. Second one, method based on finite difference operator. Finite difference operators. And third method is a method based on undetermined coefficient. So, there are three methods to find out values of a numerical differentiation. So, in this lecture we are going to discuss about two methods, method based on a interpolation and method based on a finite differences. Later on we discuss, in a next lecture we discuss about a method based on a undetermined coefficient. So, what is the meaning of a method based on a interpolation? Basically, in a numerical differentiation, if we try to find out the value of a derivative near to the first value, then we use the forward interpolation formula in order to find out a numerical differentiation or derivative near to the first value or derivative at a first value. If we try to find out a derivative at last value or nearer to the last value, then we use the backward interpolation formula in order to find out a numerical differentiation. And if we try to find out a derivative at a central value or near to the central value, then we use the central interpolation formula. So, one by one we discuss about a method based on a interpolation. So, now we discuss about a method based on a interpolation. Method based on a interpolation. Method based on interpolation. Method based on a interpolation. As we know that if we categorize the method of a interpolation, there are basically two category of a method of a interpolation. Interpolation methods of a interpolation for equal class interval and methods for a interpolation of a unequal class interval. In case of a equal class interval, there is a forward interpolation formulae, backward interpolation formulae and central interpolation formulae, and in case of a unequal class interval, there is a divided difference, Newton divided difference formula and Lagrange interpolation formula. So, here again if we categorize the numerical differentiation based on an interpolation, there are two categories. First one, method based on interpolation for equal class interval. Equal class interval. equal class interval. Equal class interval. In this category, as we know that there are forward interpolation formula, backward interpolation formula and central interpolation formula. So, here again we categorize this method based on a forward interpolation. Based on a forward interpolation, based on a backward interpolation, and method based on a central interpolation. Central interpolation. So, very popular formula under the category of a forward interpolation formula is a Newton-Gregory forward interpolation formula. Under the category of a backward interpolation formula, Newton-Gregory backward interpolation formula. Under the category of a central interpolation formula, there is a Gauss forward interpolation formula, Gauss forward central interpolation formula, Gauss backward central interpolation formula, Stirling central interpolation formula, Bessel's central interpolation formula, Laplace-Everts central interpolation formula. So, under the category of a central interpolation formula, there are several formulae. So, here in this lecture, we are going to use forward interpolation, means we are going to find out derivative numerically with the help of a forward interpolation and with the help of a backward interpolation, and in a same manner there is a derivative based on a central interpolation formulae. So, one by one we discuss about a method based on interpolation for equal class interval. Similarly, method based on a unequal class interval. Second category is a what? Second category is a method based on unequal class interval. Based on interpolation for unequal class interval. So, there are two most popular method under the category of a interpolation for unequal class interval. First one is a what? First one is a Newton divided difference, Newton divided difference interpolation formula. And next one is a Lagrange interpolation formula. Lagrange's interpolation formula. Lagrange's interpolation. Although Lagrange's interpolation formula can be used for the equal class interval as well as for unequal class interval, but in general we use the Lagrange interpolation formula for the unequal class interval. So, we also discuss about these two methods also, how we find the derivative with the help of Newton divided difference interpolation formula as well as with the help of a Lagrange interpolation formula. So, first of all we discuss method based on a interpolation for equal class interval. First one is a forward interpolation formula. So, numerical differentiation, here we write what? Numerical differentiation based on Newton's forward interpolation formula. Forward interpolation formula. So, as we know that, what is the forward interpolation formula? Forward interpolation formula is a what? Y equal f of x plus hu x0 plus hu, because x minus u equal what? U equal x minus x0 upon h. So, this one is x0 plus hu. You may also write this one equal what? This one equal fx equal y equal f of x0 plus hu. What is the first term? First term is a y0 plus u del y0 plus u minus 1 upon factorial 2 del 2 y0 plus u minus 1 u minus 2 upon factorial 3 del 3 y0 and so on. What is the last term? Last term is a u minus 1 u minus 2 up to u minus n minus 1 divided by what? Divided by factorial n del n y 0, where u equal what? Where u equal this one, u equal x minus x0 upon h, u equal x minus x0 upon h. And what is the del y0? Del y0 is a first order forward difference, del 2 y0 with a second order forward difference, del 3 y0 with a third order forward difference of a first term, and del n y0 with a nth order forward difference of a first term. So, as we know that, what is the value of a dy by dx? Here y equal f of fx equal y equal f of x0 plus hu plus y0 u del y0 u minus 1 del 2 y0 del 3 y0 and del n y0. Here y0 be a constant, del y0 be a constant, del 2 y0 del 3 y0 del n y0, all these terms be the constant. So, y is a function of a what? Y is a function of a u. This one is a function of a u. So, what is the value of a derivative? So, what is the value of a derivative? If we write here that y dash or dy by dx, if we write f dash x equal what? Equal dy by dx, and since y is a function of a u, so there is a need to write this one dy by du into du upon dx by chain rule. Dy by du into du upon dx. Now, what is the value of a dy by du and du upon dx? So, here if we see the value of a u equal x minus x0 upon h. So, if we find the derivative with respect to x, so what is the value of a du upon dx? So, here from this one du upon dx equal to what? Du upon dx equal 1 upon h. Du upon dx equal 1 upon h. Now, we differentiate this one with respect to y. So, from if we write this one is equation number 1. So, if we differentiate equation number 1 with respect to x, then what is the value? The value become what? F dash x equal dy by dx equal du upon dx be the 1 upon h. Here we write the value of a 1 upon h, then we differentiate this one, the equation 1 with respect to u. Then what is the first term? First term is a constant. So, what is the value? Value of a differentiation become 0. The differentiation of a first term is a 0. The differentiation of a second term is a what? Del y0. because differentiation of a u is a 1. So, this one is a del y 0. What is the differentiation of a third term? Third term, so if we simplify this expression, this become u square minus u. So, if we differentiate this one, this become differentiation of a u into u square become u square minus 1. So, u square minus 1 differentiation become what? 2u minus 1 divided by factorial 2 with a 2 and del 2 y 0, del 2 y 0. Similarly, what is the third term? Third term, 3u square minus 6u plus 2. This one is a differentiation. Divided by what? Divided by factorial 3 means a 6. 6 and del 3 y 0. In a similar manner, we write all other terms. So, here we deleted this term, this one. So, if we synchronize this one, so this one is a value. Once we verify this value, either this one is a correct one, this or not. So, this one is a correct one. So, here f dash x equal dy by dx, du upon dx with a 1 upon h, and differentiate this one with respect to u. First term becomes 0, second term become del y 0, third term become 2u minus 1 upon 2 del 2 y 0, and fourth term become 3u square minus 6u plus 2 upon 6. Okay. So, this one 3u square minus 6u plus 2 del 3 y 0, del 3 y 0. So, this one is a what? This one is a value of a derivative at any value at initial point, at means a starting point. You may also find the derivative at starting point at x equal x 0. So, if we put x equal x 0 here, then what will happen? Say this one, say this one here, this one is a formula of a what? Formula of a first order derivative. If we try to find out the value of a derivative at x equal x 0 or nearer to the x 0, in other word, we try to find out the value of derivative near to the first value, near to the starting value or at the starting value. So, if we try to find out a near to the starting value, means then we find the value of a u, and once we find the value of a u and find the finite difference table and putting the value of a del y 0, del 2 y 0, del 3 y 0 and del 4 y 0 and so on, and also putting the value of a u, then be able to find out the value of a derivative at any starting point, at starting value, near to the starting value, near to the first value. So, if we try to find out a second order derivative, so it is not a very tough task. Once again we differentiate this one, then this become f double dash x, differentiate again, differentiate again with respect to x, then what will happen? This become f double dash x equal d by dx of a dy by dx, or this one is a d by du of a dy by dx into du upon dx. So, we have already the value of dy by dx. So, here we write the value for du upon dx. So, this become du upon dx is again 1 upon h, the value for du upon dx, because u is a what? Since u is a what? U is a x minus x 0 upon h, x minus x 0 upon h. So, du upon dx is a 1 upon h. So, first we write the value for du upon dx here. Here we write the value for du upon dx, then d by du of a what? Dy by dx. Here we put the value for d by dx, this one is a 1 upon h, inside del y0 plus 2u minus 1 upon 2 del 2y0 plus 3u square minus 6u plus 2 divided by what? Divided by 6 del 3y0 and so on. How many number of a term? Not a finite term, there is an n term. Okay. So, if we simplify this one, then what is the result? Result is a what? Result is a f double dash x equal, if we simplify 1 upon h with a constant, it has become outside from the bracket. So, 1 upon h, this become 1 upon h square. Inside, if we differentiate with respect to u again, then d by du of a del y0, since del y0 be a constant, so the value becomes 0. If we differentiate this one, then this become 2 by 2, this become del y0, del 2y0, and if we differentiate the third term, then this become 3u square becomes 6u minus 6, and 6u minus 6 divided by 6 means a u minus 1, 6u minus, this one is a 6u minus 6 divided by 6, and this one is a del 3 y0 and so on. This one is a what? This one is a second order derivative. Similarly, be able to find out a third order, fourth order and nth order derivative, and here putting the value of a h, putting the value of a del 2y0, del 3y0, del 4y0 and the values of a u, then be able to find out the value of a second order derivative at any value for any value of a x nearer to the first value. So, this one is a way how we derive the formula for the numerical differentiation. If we use here we use the what? Here we use the forward interpolation formula, and if we use here the backward interpolation formula and repeat this process, then we able to get the formula for the derivative using the backward interpolation formula. Or if we try to find out the derivative nearer to the last value, then it must be necessary we use the backward interpolation formula, and if we try to find out the derivative nearer to the central value, then we try to use the central interpolation formula, means either Stirling formula or Gauss forward, Gauss backward, Bessel's formula or Laplace-Aubert formula based on the value of a u. If u lie between -1 to 0, then we use the Gauss backward interpolation formula. If u lie between 0 to 1, then we use the Gauss forward interpolation formula. If u lie between -1 by 2 to 1 by 2, then we use the Stirling and Bessel's formulae. So, in this way, be able to derive the formula for the derivative near to the first value, near to the last value, near to the central value, if the data is given for equal class interval. For the equal class interval, and for the unequal class interval, here we write a what? Here we write a Lagrange interpolation formula, or we write what? Or we write a Newton divided difference formula and differentiate the Newton divided difference formula and Lagrange interpolation formula, then we able to find out a formula for the derivative for the unequal class interval. So, this one is a summary how we derive any derive interpolation formula for the derivative. So, another very interesting things, if we try to find out the value near means at initial point, at starting point at x0, or last value at xn, or middle value at x equal x0, means a middle value with the x0. So, what will happen here? So, this formula become what? Become very interesting if we use what? If we try to find out the derivative at initial point. If we closely observe the value of a u, u. So, at starting point, what is the value of a u? The value of a u become what? The value of a u becomes 0. If the value of a u becomes 0, then what is the value of a derivative? F dash x equal del y 0, and here this become minus 1 by 2, this become 1 by 3, and so on, because this term becomes 0. Because u becomes 0, so this term becomes 0, this term becomes 0, this term becomes 0. Then what is the f dash x? So, if we write here dy by dx means f dash x at x equal x0, at x equal x0 equal dy by dx at x equal x0, this become what? 1 upon h, and inside what is the first term? First term become what? First term become del y 0, second term become minus 1 by 2. So, this become del y 0 minus 1 by 2 del 2 y 0 plus 1 by 3 del 3 y 0, and so on. This one is a formula for the first derivative at initial point at x equal x0. Similarly, if we try to find out a second derivative, then f double dash x become what? F double dash x at x equal x0 equal d2y by dx square at x equal x0 become what? 1 upon h square here del 2y0 and what will happen here? If we put u equal to 0, then this become minus 6 cancel out, minus del 3 y0 and so on. This one is a second order derivative at initial point if we derive the formula with the help of a forward interpolation formula. So, if we try to generalize this one, then what is the formula? F r x at x equal x0 become dry rth derivative dxr at x equal x0 become what? 1 upon h to power r, and first term with the del r y0 plus this become minus r by 2 del y del r plus 1 y0 plus what? What is the formula? Once we verify this one, r 3r plus 5 by 24, r 3r plus 5 by 24 del r plus 2 y0 and so on, not an infinite number of terms. So, up to n terms. So, this one is a general formula. If we try to find out what? If we put here r equal 1, then this become 1 upon h del y0 minus 1 by 2 del 2 y0 plus 1 and 5 plus 3 8 by 24 1 by 3 del 3 y0 and so on. If we put r equal to 2, then this become 1 upon h square del 2 y0 and this become 2 by 2 and minus del 3 y0 and so on. In this way, we able to write the derivative of any order at x equal x0. So, these formula that we derive with the help of a what? With the help of a interpolation formula, with the help of a forward interpolation formula. If we derive these formulae using the forward difference operators and shift operator and differential difference operator, means with the help of a three difference operator, forward difference operator, shift operator and differential difference operator, then we able to find out what? Then we able to find out again these formulae,